Hello, my name's Neil, and today I'm going to be talking about how to use large language models, or basically giant math problems that are able to convert ideas into numbers. What if I told you you can turn any idea into a number? Okay, what's the point? In this case, turn qualitative research into quantitative research. Sociologists, most scientists have been performing qualitative research by conducting interviews, right? Person to person, woman to woman, guy to guy, guy to woman, woman to guy, talking about things. And then they write down those things. And then they take those things that they wrote down and put them on a piece of paper, put that piece of paper with a bunch of other pieces of paper, and put that in a file cabinet, right? And now, if a really smart sociologist wanted to conduct qualitative research, what they would have to do is read a bunch of these documents and then use the computer in their brain to articulate some insight from that set of documents. This is sociology at the moment. Or maybe it's not, and maybe I'm stuck in the past, and maybe I don't really know what's sociology at the moment because I'm not a sociologist. But yeah, this is what I think sociology is at the moment, right? You're conducting qualitative research manually, and you're extracting insights from this qualitative research manually. What do I mean manually? Okay, so like, if I perform a basic study, a basic quantitative study, where I'm calculating or I'm trying to figure out what's the average GPA of rich people versus poor people, right? This is a very simple research to conduct, okay? I would ask 100 rich people, what is your GPA? I would ask 100 poor people, what is your GPA? And then I would compare the two averages and say, wow, look at this. Rich people have better GPAs because they have access to more academic resources. So there's some kind of conundrum when it comes to how we're distributing access to education across the wealth barrier, right? So this is the insight I would get from comparing essentially a handful of numbers and automatically calculating the relation of those numbers using math. Okay. And when people get into qualitative research, their brain immediately turns off the quantitative. They're not the same thing. But what I'm trying to say is that the separation that we have between words and numbers is an arbitrary separation in our minds. Essentially, they're the same thing. They're both metaphors used to describe the same reality. So here's what I'm trying to say, right? Stop separating words and numbers. They are both metaphors used to describe the same reality. The field of sociology is limited by our mathematical understanding of complex objects and how they relate in complex geometric spaces. However, am I repeating myself? I might be repeating myself. Economy, the distribution. One second. I'm gonna get to this point and how economy of power. That might be backwards. I wrote economy of power. Economy of capital. What is an economy? An economy is a distribution of a particular thing over a network of things. For example, the economy of wealth is the distribution of wealth over a network of people. The economy of power is a distribution of power over a network of people. That's a tangent. Now, oh shit, that is a tangent. Imagine this. This is how we're gonna innovate in sociological research, right? Imagine you ask me how I'm doing, okay? You're like, Neil, how's your day been? How's your emotional life? How's your financial life? How are you doing? And in my head, I'm thinking all these various things, right? And then at the end of that, all these things I thought, I converted into a list of numbers, okay? A list of numbers called a vector. And then I give you this vector, and then you look at the vector, okay? And then your brain consumes that data, right? It consumes that number, that vector, same thing, basically. It consumes that number, And then immediately, in that ephemeral moment when that number has gone through your brain and it provides a sensation to your whole being that completely helps you understand what I'm going through right now. I didn't tell you through words. I didn't say my car broke, my house blew up, my dog died. I didn't say any of those things, right? What I told you was a list of numbers, and you immediately understood everything about my situation. Now, that might seem bizarre to you and completely unreasonable, but that is what AI is attempting to do. It is attempting to take reality and turn it into a bunch of numbers, right, that give a box around reality, right, in an attempt to describe reality. Infinitely trying to get better and better, coming up with more numbers and more numbers to describe reality. But at the end of the day, all you're left with is a fucking approximation. Let me talk about this approximation, okay? This is how language models, large language models work, right? You give it a word, hello. It turns that word hello into a vector called which is a set of a sequence of tokens that represent each letter in the vector, and then it takes that vector and passes it to a transformer. This transformer takes this vector and fucking transforms it, okay? And it transforms it into an embedding. Embedding is basically a fancy word for another vector. But the difference between the vector you gave it and the vector it came out with is that the vector it came out with is the understanding of what you told it. It is the meaning of that vector, okay? So, vector of words that have no meaning, you pass it through a filter called a transformer, and on the other side, you get another vector that describes its meaning, its understanding. And literally, what these language models are capable of doing is the same way 1 plus 1 equals 2, and 2 minus 1 plus 3 equals 4, right? It's the same thing as having two vectors. There's no point in even drawing it. It's the same thing as having two vectors, where one vector is king, okay? This is king. And then you subtract man from king. So king, man. And then you add woman. It goes over here. And then that vector is queen. I'm not even king. That's literally how vectors in language models work. So what I'm trying to say, what I'm trying to articulate is that these machines are capable of extracting the meaning of a set of words into an idea. Okay? King minus man plus woman equals woman. Vector addition and subtraction. Simple. Here's what I'm describing. Imagine this vector means king. You subtract man from it, right? You add woman. Okay, this is the woman vector, and then you get a new vector that means queen. This point in space, in 3-dimensional, 1 billion dimensional space, means queen. This vector means man. This vector means king. You subtract man from king. You add woman. You get queen. That's how vector algebra with embeddings work. Now imagine this. Instead of me asking you a question, which is a simple number, like how tall are you? And you say 5'12", all right? Instead of me doing that, I ask you for your whole life story, okay? I asked you for your whole life story. You tell me your whole life story. I sit there for 4 fucking hours, okay? And I'm listening to you, right? But I wasn't listening to you. I was recording it, okay? I took that recording, I put it through an AI. I told the AI to extract the text from what you said. And then I take the text from what you said, and then I pass it through a transformer. And then that transformer gives me a number, okay? And that number describes the context of your entire life story. So that'll give you an example, right? Qualitative research. So this is a qualitative research sample format, which is intended to investigate, how first-generation immigrant students deal with their life in college. So what this research study proposes is you go ahead, you talk to 50 students, right? You hang out with them, you take all their life notes, and you find out the unique ways they deal with school. They deal with being a first generation immigrant in a new country. Okay? You take all that information, and then you come to conclusions on it. This is the original way you would perform this sociological research, right? This is one way. Now that I've explained to you how these things work, right? And mind you, I spent like weeks trying to read this. I don't get it completely yet, okay? I don't. This is a very high level understanding. Anyway. Okay, imagine this. You have a database. That's water. Imagine this. You have a database, okay? You have a database. This database holds data. Man, that is not readable. Okay, this is a database again. It's drawn in black. Oh my god, it's still not readable. Yeah, whatever. Yeah. Here's one thing I want you to understand, right? When you have a document and you convert that original document into an embedding, you get a point in space, right? Now, if you chunk up that document paragraph by paragraph, and then you convert all those paragraphs into vectors, right? And then you add all those vectors together, you're going to get a similar vector to the original vector the model generated when you pass in the first big document. So we get to understand the same way you can add numbers together, you can add ideas together, experiences together, okay? Average them out. Find the mean, find the height, find the mode, find the median, all those things you can do. So you have this database, and you have 3 rows in the database. In the first row, you put the user identity, your social security, your name, your email, your identity. Okay. Then in the second row, we put an entire essay, not an essay, of everything you've uttered to the researcher in that 1, 2, 3, 4, 7 hour meeting. Okay? Everything you've uttered in text. Okay? In text. And you put that in the second row of the database. Okay, now the third row of the database, all right? You take that giant thing that you just uttered and you give it to the machine. The machine gives you another vector. You can think of the vector as just a number. We'll call it X, okay? And that vector describes the idea of what you just said. Everything, the context, the semantic essence of what you said. Meaning. What you said, and the semantic meaning of what you said as a vector. And we'll call that vector X. Great, right? You have one person's entire life story represented as a sequence of numbers. Now, you repeat that. With, let's say, 50 people, okay? 50 people. 1, 2, 3, 4, 5, all the way to 50. Okay, now you got 50 people's entire life story represented as a vector. Okay, but see, now you're conducting this research. You're like, man, talking to 50 people, I'm tired. I don't want to talk to so many people. I don't even like people, okay? So you're like, how do I automate collecting sociological data, semantic information from a bunch of people? What you do is you create an AI chatbot. You name him Harvey, all right? And Harvey is this amazing new student at Santa Clara University, okay? And basically, he's like, all right, listen, guys. You don't know me? He got your number. Like, oh, shit, he got your number. How the Oh, I guess he just, that smooth with it. So Harvey got your number. He's that smooth with it. And now he's texting you. All right? He's texting every student at this school. Harvey is either Harvey or she's either Mary. You never know. It's Harvey or Mary depending on who you're talking to. It doesn't matter. Harvey or Mary, they're talking to you, right? And they talk to you continuously. They ask you random questions throughout the day, maybe throughout the week. I don't know, all right? Through the month. But, but they're kind of distant, okay? They're over there. I'm over here, they're over there. They're talking to me through the phone. They're asking me questions. I'm listening. I'm answering these questions. I'm like, this guy's interesting, but I never met this person. But it doesn't matter, okay? Now the sociologist Neil Gawande, or whoever the fuck you are, right, has now a giant database full of you, everything you've ever said, and then the vector that represents everything you've ever said. This is how I would do, the qualitative research aspect of it. Now, if you think about it, this type of qualitative data is the same kind of qualitative data. It's not the same kind, it's definitely different, but it's in the same spirit as a man working on the side of the street selling melons to the local, shop goers and observing, right? It's the same thing. He's observing, he's collecting data. In this situation, you automated it through the medium of communication that most people rely on today, which is technology, which is in its own way a sad thing to say. But anyway, now you have a bunch of people, everything they've ever said in a vector. Now, instead of visualizing this as a table, you visualize it as a three-dimensional space with height, width, and length, right? So you have this, that space. Okay, now understand that this is not actually how big the space is. This space has a dimension of 3. That's the wrong way of thinking about it. When you're dealing with vectors that capture your entire life's meaning in a number, it's actually a point in space with millions, billions, trillion, gajillions of dimensions, okay? My feeble mind can imagine this, okay? 2-dimensional, 1-dimensional, maybe 4-dimensional, but 1,000-dimensional, I'm not there yet, okay? And I'm pissed. Imagine, okay, I'm stupid, so instead of thinking about it in 1,000 dimensions, I'm thinking about it in 3 dimensions. And I have the list of vectors, right? Person 1, vector 1. Person 2, vector 2. Person 3, vector 3. Person 4, vector 4. I have a vector representing all of these guys. This is my data set. This is my sociological research, okay? This is what I've conducted thus far. So now I have this vector over here, this vector over here, and this vector over here, okay? These are 9 people. There's millions. In this situation, I've only put 9. Okay? 9 people. Wow! Look at that. Why are there clusters? Why are there clusters of vectors here? 1, 2, 3. I've taken your entire life story and I've taken the semantic context and put it as a number, and then I mapped it into a space, and then now I can clearly see with my eyes that you guys have different experiences. Then boom, I'm the sociologist. I care about people, okay? I have empathy, even though it may not seem like it, I do. So I'm like, what the fuck is going on, right? So then I immediately notice there's a distinction. And then let's say I take a vector, a random vector from that set of vectors in that cluster, right? And I look at it, I'm like, wow, this guy is a first-generation immigrant, okay? He's from fucking Zimbabwe, right? And oh my God, dude, this other guy's from Afghanistan. This other dude's from North Korea. He escaped Kim Jong-un. This woman is a woman from Afghanistan. Holy crap, what the... And listen, all these stories are connected, right? And they're semantically clustered. And then there's this group of kids who came from China, and this group of kids who came from money, and this group of kids who played sports their entire life, and their semantic experiences have been clustered. That's emergent sociology. I went in with no particular question, and I came out with a bunch of answers, right? That's one approach. But, let's put this to the context of trying to understand how students at Santa Clara are feeling about their life. How students at Santa Clara are feeling about their lives and the unique challenges they're facing and the unique reasons why they're experiencing those challenges, and the distribution of stress across this network of people, and who's experiencing stress and who's sad and who's happy and why, and what situation are you in? These are the questions we want to figure out, right? This is the social computation that we need to perform. The sociologist is what I'm saying. Okay, so we're gonna have one basic example. You have a million. That's how many students at Santa Clara. You have 5,000 vectors at Santa Clara. 5,000 people. Okay, and they're all ping, 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 going all over in this n-dimensional space, right? And then the same way, you have a piece of paper, and then you have a line like this, and then you collapse. You project this line onto the plane. You get a new line, right? You take this, you collapse it, let's say you have a line going like this, you collapse it, you get a new line. And the line on the plane is the projection of that higher three-dimensional vector onto this two-dimensional plane. What you project each person onto a plane that describes their position in their academic position in school. Are they an engineering student? Are they a science student? Are they an art student? Are they a business student? Okay? And then look at this, right? You take that high dimensional, right? Oh my God, I have no idea what this is. Holy shit! And then you project it onto a plane. Okay, you project it onto a plane that has, you know, art students over here, business students over here, engineering students over here, and science students over here. A plane, a plane. Okay, flat surface. All right, flat surface, and you have vectors going like this. The vectors that came here are art students, engineering, business. You get the idea. And then for each vector, let's say this guy over here in the business student degree, right? What we do is we take this guy's original document, okay? The original document where this guy told me his whole life story while he thought I was Antoinette from Russia, okay? Okay, I take his whole life story, and from that life story, I take a chunk out of it. You know, just the piece of it. I ask a ChatGPT or some AI to go through the text and say, take out the part where this guy talks about how stressed he is, okay? Then I take that chunk and I turn that into an embedding. I turn that into a vector v. And then I pass that to this vector, and then I get a point. A point that describes how, from a scale of 0 to 10, how stressed is this guy. Okay, boom. Let's say he's a stress level 5. Okay, 5. Then for each person, I give them a corresponding point describing how stressed they are. You know, art students are stressed maybe this much, business students maybe this much, science students maybe, you know, maybe this much around here, and then engineering students all the way up here. Holy crap, what the hell is what is going on? So you have a plane, okay, split into 4 quadrants. You have vectors going like this, vectors going like this, vectors going like this, vectors going like that, and then boom, all of a sudden, you look at the plane and it's a curve, okay? It's a curve. You have a curve that approximates, based off your position in educational space, the level of stress you have. Boom. That's one thing you can do relatively simply, you know, from like, you know, putting it into a computer to give you the results, and boom. Now, if you take another student who wants to be, you know, who is a, let's say, you know, he's coming into school, he's new, or she's new, it doesn't matter, right? And she says, you know what? I want to be an engineering student because I'm fucking, yeah. And then she's like, oh crap, I'm gonna have a lot of stress based off, you know, the prediction of the school. Sociology. That's one version of sociology. Or I'm Julie Sullivan, and I'm like, wow, there's a huge discrepancy in the amount of stress engineering students are experiencing compared to everyone else. This is a huge problem. We gotta fix this. We gotta make sure everyone's experiencing equivalent numbers of stress. How do we do that? We gotta stress these guys out. Ugh. Sociology. Okay, this is another application. Sociology. You're examining the particles that construct the social body. The same way you examine the particles that construct matter. Imagine this: you're trying to figure out how you want to explore how you know, low income students are dealing with college, and you want to take a very specific slice out of that and explore a very particular niche within the whole data set. Okay, so here's what you do. I want to find out a very specific questions. Okay, of the engineering students who have a tutor but can't afford it, what are they doing to receive tutoring? Now, if I went ahead and asked that question to a bunch of people, right, that's going to take me 1,000,000 years to find even 50 people who find that exact description. Not 1,000,000 years. It's going to take them a lot of time. So instead, what you can do is have that giant data set of everyone. Then from that data set, you ask a question. How many of these students are engineering students? Engineering, business, these are 3 different clusters. These ones are the engineering ones. And then you ask, how many of these engineering students have tutors? Okay, then there's students who don't have tutors and the students who do have tutors. And then you ask a question. I know you don't have a tutor, but can you afford one? And this person says yes, and this person says no. And these people over here say, this person, these people who you ask, do you have a tutor? They say, yes, I have a tutor. And then you ask them, can you afford it? They say, yes. Or some people might say, I have a tutor, but I can't afford it. So, wow, what a unique situation to find yourself in. You can't afford a tutor, but you have a tutor. Okay, what's going on here? What sociological phenomenon is happening? So, you take that subset of people who have a tutor and can't afford one, and then what do? So, here's what you do. You found that subset of people over here that have a tutor but can't afford one. So now you have a list of people, right? X, R, T, whatever. Each of those people have an original document associated with them. So you go to that original document, okay? And then you find the part of the document with, some AI and ask it, what strategy does he use to have a tutor when he can't afford it? And then we convert that strategy into a vector. And then we do that for a bunch of people, okay? Now we have all the strategies of how these people who can't afford tutors have tutors at SCU. And then we map all those vectors in a space, and then we cluster them. And then when we identify the clusters, what we end up getting, this is strat 1 and this is strat 2. As a sociologist, now I've identified with computers the unique strategies people employ at SCU who can't afford tutors, how they afford tutors. And then who cares, right? I'll take the same format and ask slightly different questions. Of the students who don't have access to a tutor, who want access to a tutor, how do I help them? Right? And you can quickly find those people, from the database, essentially. I can find people who have similar experiences. See, this person over here has this experience, and this experience has this vector. This guy over here has this experience, which has the same vector. So that means this guy and this guy had a similar experience. What is that similar experience? What groupings can I make of people who have similar experiences, right? That's one sociological research method. Maybe I cluster everyone, and then I create a knowledge graph with friends. This guy is a close friend with this guy is a close friend with this guy. All these guys are close friends with the first guy. But see, this guy over here knows this guy, is friends with this guy by like 3 relations. So that means he's not that close of a friend. But then I can ask a question like, these friends, or if I have 2 friends, let's say, that are linked across 2 distinct clusters, and then I take all set of people who are friends with people who are in a completely different clusters than them, I take them and try to find the common patterns of these relationships. What makes these relationships so unique that they're able to, have friends across clusters, across social groupings and hierarchies? What do these people represent, right? That's basically my rant. I'm gonna read my last thing. With large language models, we will be able to generate a vast corpus of semantic experience, and then with great efficiency be able to extract key insights from the data, based off which every query... With large language models, we will be able to automate and generate a vast corpus of semantic experience, and then with great efficiency be able to extract key insights from the data, based off whichever queries you can possibly fathom, all right? And then my final point is that there's a certain anthropocentrism, which is basically like saying humans are racist to other species, okay, or other things in this universe, where we think we're special, okay, that we're somehow different, that we're God ordained in some fantastic way that other things aren't, okay? The same way I'm, like, if I'm anthropocentric, I think that this bottle is less important than me. But I'm like, someone who doesn't have anthropocentrism would say, this bottle is just as important as you because God made both of you, right? Now, the actual logic and, value and however you agree with the statement is out of the question. That's what anthropocentrism is. But what anthropocentrism does is it blinds you off from like a higher perspective, okay? And that higher perspective is that humans are just like everything else in this universe. We have the same experiences that other forms of matter have: particles, protons, electrons, cows, dogs, trees, cows, chairs, and cars. Okay, all these things are important. All these things are subject, or maybe not subject, but they are part of this amazing physics. They follow laws and equations and patterns, and if you look at it from a bird's eye view, you can see beautiful geometric patterns, like, you know, atoms with their poles and their fucking electron clouds, or cows and their herds, you know, or birds and their flocks, or trees and the mycelium networks they generate underneath the roots. Right? They form these geometric patterns, and you look at it from above. What are these things doing? And why? They're alive, like you and me. We create these weird stories and dramas and poetries with our life, and you can see it from a bird's eye view, like a bunch of flowers or something, like something cool, you know, something pretty, something beautiful. The same way that a physicist will look at, you know, the distribution of an electric charge across an electric field, a sociologist asks the same questions. How does the stress charge travel across the human field of relations, right? Us humans, we create a field of relations. We're connected. The same way I have a field of cloth over here creating this clothes, there's a field of humans. In the same way, when I click something and energy goes through this field and signals get transmuted and communicated across particles, when this guy in this social network and this, the CEO is experiencing stress, right? How does the stress spread through the network? How does it move through the field, through the space of relations of human beings? So, happiness, how does love, right? How does hate, how does anger, how does lust, how does it make its way through this field? What shapes does it have? Is it spinning? Is it fucking dancing? Is it going down and up and down and up and dancing? Like, look at the motion of the energy through the field the same way I look at a gust of wind going through the sky, right? Whoosh! Love! Yeah. That's the future of social physics, I think, probably. I hope so. The challenge of sociology, the great challenge of sociology is to have an empathetic understanding of the human experience. And I would argue that social physics is more complicated than particle physics. It is easier to gauge the state of a proton than as opposed to a person. The same way an electric charge. Yeah, that's basically what I gotta say. Yep, okay. Gotta mention this. These are like the final cliff notes. Convert raw data into semantic embedding. Convert interviews into semantic embeddings. Dynamically generate relations between actors in a complex network. Cluster semantic responses and states of actors. Find distribution of a semantic concept over a relational space. Automate sociological research such interviews with personable bots. Spread that communication over time to lower its impact on people. Evaluate the semantic state of individuals by aggregating different data sources. Identify how semantic influences spreads through relational space. Extract scalar value from embedding context. Yep.